Today's project is Rhythmia by KuroFurtex. We're going to be reviewing this code in just a minute, but first, let's run the game. Okay, we've got a nice little menu screen. I'm going to turn the volume down for now. So right off the bat, this seems reasonably polished. We've got a menu, we've got a settings screen. Somewhere in a galaxy, there's two fluffy furry named Kuro and Zyro. Kuro is a QT professional of many media, owner of a planet called KuroMatria. Zyro is Kuro's older brother. He mostly plays games every day and he doesn't have any achievement at all. One day, Zyro came to a visit to KuroMatria. Kuro, can I have this planet instead? You barely did anything. Are you blind, mate? I've been preventing raids and taking care of planet's economy. The hell are you talking about? Wow, okay, this has character. Oh, and some bad language. Let's just go beginner pack. I'm guessing this is some kind of rhythm style game based on the name. Difficulty, Ultimaz. So I can move and I can jump. So it does have a variable jump height. The longer I hold down the jump button, the higher I go, which is kind of neat. I'm not sure how I feel about the wobbly screen effect. Oh my goodness. So it's combining a rhythm game with a platformer. That's an interesting idea. I've not seen that done before. So the developer asked me to look at this from an optimization point of view. They said that the trail and the level editor make the game lag. I'm not entirely sure what's meant by the trail. I'm guessing it's this white sort of particle trail. Ooh, this level's a bit harder. And apparently there's a level editor. Yeah, outdated. Let's give it a go anyway. So I guess we have a timeline at the top here, and we can do things like change the color over time, and we can add beams and such. I'm not going to get too deep here, but it seems quite powerful. And honestly, it's not lagging at all for me. So I'm not sure exactly where the problems are, but we'll dig into the code nonetheless. Before I get too hands-on with the code, I always like to try and find the entry point and identify the main classes. What actually happens when you run the game? Which scene represents the game as a whole? I can see that the first scene being loaded is this menu v2. So let's start with that. Interesting, all the menus are sort of in the same screen here. And I guess the camera just moves around or something? My first thought, honestly, is that this scene is very, very cluttered. There's just a lot going on and there's so many elements in this scene graph that what I would personally try and do is split these into multiple smaller scenes. Because I'm struggling even just to find the button here, the story mode button, because it's just clicking on this background image. So what I want to know is this hooked up to anything? It looks like it is. Button down calls this story function. Yeah, so this is the menu script. And this is what's being called when we click on story mode, which transitions to story scene. It's really hard to make sense of any of these menus, to be honest. So I'm going to take a slightly different approach of just try and find the game scene manually in the file system here. Gameplay UI sounds like it's probably used during gameplay. So what we can do is view the owners of this. We can see it's used in level. So level is probably the main game scene. And that looks promising. So I think this is probably a good place to start if we want to dig into what's actually happening during gameplay and how can we optimize this. As I was digging through the project a little bit more, I came across this horror. And you know it's bad because it starts with the comment, "Welcome to the hell I've created myself. Enjoy your eyes with this comically large chunk of code. Alert, don't hope the editor to function properly after you remove one line of code." And sure enough, this is a lot. You've got these gigantic functions. You've got what looks like a ton of data embedded directly into the code here. You've got these enormous switch statements, or match statements as they're called in Godot, where it's basically just doing a completely different thing depending on some parameter. You've got a lot of nested code here. I don't even want to begin to think about what sort of data structure we're dealing with here. You've got variable names which don't even pretend to tell you what they do. It's a mess. With a project like this, it's really hard to know where to start. Refactoring all of this would take weeks, so we're just going to have to focus on some of the worst offenders. They did say in their email to me that there were some frame rate issues, and there are basically two functions which are called onTick. You've got process, which is basically called every frame that the game is rendered. So if your game's rendering at 120 Hertz, this will be called 120 times a second. And then you've got the physics process function, which is called at a fixed rate, regardless of your monitor's refresh rate. And this is based on the physics frame rate, which is defined in your project settings. So if we're concerned with the lag and trying to improve performance, these two functions are the place to look. So let's start with that. They're both horrific, which is going to make them all the more satisfying to refactor. So we get the song duration from the level data. And this is the first place where we can start to improve things, I think, because rather than making this a dictionary, let's make it a resource. Just for now, I'm going to put it in a folder called level, and we're going to make not a resource, but a script that defines a type of resource. So I'll explain a bit more about that in a sec, but let's just call this level data. And this is going to extend resource. And basically everything that is in this level data dictionary is going to become a property of this resource. Defining our data structure in this way has a lot of benefits over using a dictionary, as we'll see later. But essentially the idea here is to make all our properties and their types as explicit as possible, so that we, as the developer and the compiler, can reason about them. Okay, what else am I going to do here? I'm going to make sure that everything adheres to accepted naming conventions. And while we're at it, let's rethink some of these names. I mean, var gap equals false. It's impossible to know what this variable is doing from the name alone. So that to me is a bad sign. So let's look at gap, see where it's being used. If level has gap, then even though we're going to be changing this again a bit later, I wanted to show that all of this here can be replaced by a call to the dictionary's get method, which allows us to provide a default value in case the key isn't found. This also improves performance because it only uses a single lookup in the dictionary, whereas before we were doing two separate lookups. But more to the point, I mean, you've got this global class, which I'm scared to look at, frankly. It's just tons and tons and tons of global variables. Classes like this are very dangerous because it becomes tempting to just make everything a global variable. And at that point, it's very difficult to control or track how these properties are being accessed, if at all. And essentially it just becomes unmanageable, which is exactly what we're seeing here. But also the naming here is just very unhelpful. It's not obvious at all to someone reading this code what this is doing. And why are you subtracting 2? There's no comment, there's no explanation. All I can infer from this is that the gap tick box is maybe like giving you a little gap at the start of the level before the beat kicks in. That would be my guess, but it really is just a total guess. But nonetheless, we will call this has gap. I mean, even that is a slightly better name because you can then tell from the name that it's a Boolean without even having to look at the type. You know, okay, this is going to be true or false. Win equals 300. What does that mean? Again, because everything is being accessed through dictionaries, there's a lot of this pattern of like putting the property name in quotes. This is one of the things that we'll avoid by converting this dictionary to a resource, because when it's a resource, you can access the property directly by name without these quotes, because this is extremely error prone. What I can see is that this property of the level is being stored in a variable called winbeat. And if we look at where winbeat is being used, it's something to do with the progress. There's some sort of progress bar, perhaps. which is being set to a value of current beat over win beat. So I'm guessing that beat is kind of your progress through the level, like what beat of the song have you reached, and win beat is the end of the song. So why not call this length or num beats? And finally, since this is a resource, it's very important that we define an init function. This is actually one gripe I have with Godot, is that when defining your own resource types, there's a lot of boilerplate. As far as I know, there's no way around this, and there's no way to auto-generate this. So this is kind of how you define a custom resource. You define all your properties, and you define an init method with one parameter for each property, and then you assign your properties to the values of those parameters. Oh, I think the one thing I missed is that these should be exported. This just ensures that these properties will be editable in the inspector whenever we have an instance of this resource. Now that we've created this resource, we can replace this dictionary here with a level data resource. We just have to make sure it's actually got a name, class name. Let's call it level metadata. I think that's a better name. I did notice that that's what's commented here. So now, we don't need this comment anymore because it's self-explanatory. Let's call this level metadata. And now comes the fun part of fixing every single place where this is being referenced. So here, level data. Now, perhaps this is why they were storing this information as a dictionary, is because they're using RD level, which is an add-on. So this is actually some kind of possibly third-party tool for parsing these levels, and presumably this returns a dictionary. So this is a little bit troublesome now, because we have to parse the dictionary into our resource. Now what I'm going to do is I'm going to create a new variable here, var level metadata dict. And then we're going to say level resource equals level resource dot parse dict level metadata dict. Sorry, not level resource, level metadata. So here I'm just writing a static function which is going to take a dictionary and convert it into our new resource format. Ta-da! This isn't quite perfect, and that's because there's a good chance some of these are actually stored as strings. So yeah, if you look here, they were actually doing some conversions, and to convert this one to a bool, they were actually comparing against the string value of true. So let's do the same. We can convert this string value to a bool by just comparing against the string true. I also realized here that some types which I'd assumed to be ints are actually supposed to be floats. So I updated the type definition, and that's another advantage of having a resource like this, is that everything is very explicit. There's no ambiguity. This isn't the best way, by the way, to convert a value to a float, because this will crash if the value is not a float. I think a better way would be to say something like is valid float, and only if it's a valid float would you do the conversion. For now, I'm not going to bother with that because I just want to get this thing working, and we've got a lot of work ahead of us still. Now that we have the level resource, we don't need to access these through the dictionary anymore because it doesn't exist. We will instead, let's call this metadata. And in fact, this variable already exists at the class level, so we don't need to define it again here. Now, instead of trying to read from the dictionary, we can just access the properties that we've defined in our resource. Now, we actually know the types of the properties we're accessing. So this is much, much safer, and it means we're only doing that parsing in one place. This is where we parse the level, rather than trying to access the dictionary like all throughout the code base. So this makes all of the usages of the level metadata much, much safer, and we're just going to have to replicate this, unfortunately, all through the code base. See, now we don't need this float call here either because the type is already set in stone. So you can already see the benefits of having this resource. By the way, the reason I made this extend from resource is because that gives us the option in the future to actually create instances of level metadata and save them as resource files. Resource files are super handy because they're basically data files that can hold arbitrary types and can be edited directly in the editor. But if this functionality isn't needed, we could just as easily extend from refcounted, which is just your basic object type that's memory managed by Godot. Every time I can remove this cast to a float, I see that as a huge win. And speaking of win, we're no longer comparing beat to this random value called win, we're comparing beat to num beats, which just makes a lot more sense in my mind. Slight problem here. We have this method save custom level, which is again part of that RD level plugin. So this is going to expect the level to be in a dictionary format. So we're going to have to create another method in this file called toDict, which is going to be basically the reverse of parseDict. If I could give one general piece of advice to any beginner programmers, or really any programmers at all out there who want to improve, it would be this. Give your variables clear and descriptive names. Because then even if your code is garbage, at least someone can read it and understand what you're trying to do. It's much easier to improve code that can already be understood. I'm just going to do a find and replace here for all cases where we access an obstacle in the level. 143 replaced. Wowzers. Load level. This is doing the same thing again, is it not? I think we can extract all this to a function. I'm just going to make a new function. I'm going to call it load level metadata. I'm going to implement that down here. Load level metadata path. Let's give it a type as well. And then all of this can be replaced with a call to load level metadata. I also noticed that we're calling RD levels save function in a bunch of different places, but there was already a function to do this in the editor script. We have a save level function here, but we're not calling it. So we could just call that instead of duplicating it. And I think the same is happening elsewhere if I recall correctly. Using functions like this is a great idea in general because it just prevents duplication. It ensures that your code is going through common code paths. Now this is only called in one place, which is brilliant. So we know that we're always going to be using the right function to convert our level metadata back to a dictionary. Looks like we've only got one error remaining in this file, that is. In this file, let's not get carried away, which is when it creates a new level. The nice thing here is we already have the functionality to do this just by calling level metadata.new. And here we're refreshing all these controls, which we do also when we load the level metadata. So let's just call this refresh controls. Okay, I'm going to make this a private function because it doesn't need to be called from outside. And what this is going to do is it's going to take our level metadata and update all the UI elements. So now, instead of calling this in a bunch of different places, like in the new level function, we can just call refresh controls. And already things are starting to get a little bit tidier. At this point, I'd fixed all the usages of this dictionary in this particular file, but it's also used throughout the code base, so I had to make a bunch of other fixes. And now for the moment of truth, does the program still run? This looks promising. What about the level? Oof, okay. I've broken something. In a few places I was using the wrong variable type or the wrong name, but that was easily fixed. Ah, that's actually a dictionary, not an array. I think I just won immediately. Is that... I've hacked the game. I'm winning the levels literally straight away, so that's a bit concerning. It's all based on win beat, which should be set to num beats. So maybe num beats is not being set correctly. Sure enough, I was looking in the dictionary for num beats when I should have been looking for win. And similarly, this is supposed to be checking gap. So yeah, there were just a few mismatches where I was looking up the wrong names in the dictionary. Let's try this. Num beats is now 140. That looks more promising. I'm not seeing any obstacles, which is a bit concerning. Like, it's working, but there are no obstacles. I did a bit of debugging here, and it seems like this variable tar beat, which controls when the next obstacle is going to spawn, was being set to, like, the end of the level, because there were no obstacles inside the level metadata. And that, very simply, was because I never read them from the dictionary in the first place. And hopefully it spawns one. Yes! We're spawning. You're bound to break a few things when you do a refactor like this. But thankfully, I think it was a lot easier to understand what was going on with my changes, which made it a lot easier to actually fix those problems that we created. My original intention was to try and improve the performance of this game by looking at the process function and the physics process function. We only actually got one line into that before I went down a rabbit hole with this whole resource refactor. I do think that was a valuable change that we did there, but obviously there's a lot more work to do. I don't think this is a lost cause. I think this is totally salvageable. I think this game has a lot of charm, and I hope that the developer continues to work on this because they've obviously put a lot of time and effort into this. I'm going to briefly outline a few other changes that I would consider making. And if you want to see more, maybe I can do another video on this, but I do have a backlog of about 8 other projects to look at. But off the top of my head, here we're doing a lot of stuff to the camera. That could be moved to the camera script itself. I think there just needs to be a bit more separation. That's going to make this a lot more manageable. Try and avoid the globals as much as possible. Try and put them in a relevant class. So right now, for example, we're in the editor script. If these pertain to the editor, then maybe they should live in here rather than in this global class. We're accessing a lot of nodes using this syntax with the $, and there's nothing technically wrong with that, but it is error prone because if you change the node path in the scene tree, then all of these references will break. So one thing I've suggested in past videos is that you can right click on a node and press access as unique name, which actually allows you to refer to it by name without needing the full path, just using the % instead of the $. That would make these references a bit more robust, but I'd also recommend, instead of sort of peppering your code with node references, what I personally like to do is use onReady variables so that you get that node reference once in one place when the script loads, and then you can just refer to it using a variable. I personally find that a bit cleaner than having node references throughout your script. Also, there's just a lot going on in this method, so personally I would probably try and extract things to functions rather than having just hundreds of lines of logic in this one function. You could just call, update camera, update whatever this is, update color, update, I don't know what else is going on here, but just having those named functions makes it a lot clearer what's going on because the functions are kind of like a form of documentation in themselves. Here we are checking if a button was pressed. Really, this should use a signal. And if we have a brief look at the physics process method, it seems like this is a bad idea. You're saying, yes, this updates every frame. Very questionable, but I'd say it works. I agree, that is questionable. It might work, but maybe this is the source of some performance issues. Do you really need to update this every frame? I'm not exactly sure what this is doing, but it does seem questionable. I'm going to leave it there for this episode because this video is already getting quite long, but I hope you enjoyed this. Let me know if you want to see more, or if you have any other projects that you want me to look at. Thank you for watching, and I'll see you next time.